Hello, everybody. We are now working in our next unit folder, and the chapter that we're working on is Chapter 5, and the topic is functions. Functions is something that we've been using right from the get-go, and I think we've talked about that real briefly. So, like, for example, when we type the print statement and we put parentheses after it, that's a function. It's not something that we created, it's something that's native to the language. But we are going to learn about not only implementing functions that pre-exist, but functions that we create. And then we're also going to learn about the concept of putting your program into a format that is a little more typical for coding, and that is to create what we call a main function in a program. Also learn about the concept of passing parameters or receiving arguments. Some stuff here about breaking complex tasks into simpler ones, and that's kind of an interesting thing. We're also going to learn about variable scope, and then really quickly we'll learn a little bit about what we call recursion, although you won't have any exercises related to that, but I think it's kind of fascinating to look at. All right. Now, they have this little graphic here, and this is kind of interesting. Because when we start to code stuff, and so far we've been coding things that are relatively simplistic. We're not really, writing more than 10 or 20 lines of code. It's not really a very long program. However, you might write a program where you have certain things that you do that you might end up doing over and over again. And it makes no sense in those situations to create the same code over again to do the same task when you can just create it once, give it a name, and then call upon it whenever you need it. That, in a nutshell, is really what a function is. It's a named bit of code that you can reuse. And not just in one program, but basically any program that you want, provided you refer to it correctly. Now, for some people, they think of functions as black boxes. So let's talk about what they mean by that. When we use the print command, or look at the example that they have here, right? Price and then round, notice it's followed by a set of parentheses, and that's one of the hallmarks of using a function, is a function will be followed by a set of parentheses. That indicates that we're running a function, and we just kind of make this assumption, and we throw this like long number in there, and then it executes, it'll put 6.83, because we told it to round to 2 decimal places, inside of price. We have no need to understand what's going on in the background of that function in order to utilize it. All we need to know is what information we need to throw at it and what kind of thing it sends back. So I know that if I throw in a decimal number that's got like 1,000 places after the decimal point, and I set that second parameter to 2, that I want you to round that number to 2 decimal places, it just does it. Who cares what the mechanics are, right? So that's why they kind of refer to these things as a black box. The interesting thing is, you're going to hear terminology thrown around in your programming classes relative to the stuff that goes inside the parentheses, so the stuff that's inside here. If you are sending a value to something, it's called a parameter. If you are inside the function receiving it, we call that an argument. So often you hear programmers use those terms interchangeably, but there is really a correct way to utilize them. So relative to the function itself, it's an argument. Relative to the outside world, it's a parameter. So sometimes functions will return something to us. So you see how they highlighted return value. That rounding function returns a rounded number. That's what it does. Okay? Sometimes you write these things and they don't necessarily return anything, they just do something. Sometimes a function's job is only to run other functions. How do you like that? It's kind of a weird one right there. All right? So functions can receive multiple values. The round function receives 2. It receives the number you're rounding and how many decimal places, and it just kind of does its magic. All right, so that's some of the key precepts there. If you are custom coding a function, it's really kind of up to you as a programmer whether or not you're actually returning something back or not. Regardless, if you are creating a function that returns a value, you have to know that it's got to have somewhere to go afterwards. So here, let me explain what I mean by that. Up here, I'm doing the rounding. Because we know that's going to send a number back, that has to have somewhere to go, so we throw that in price. So often, you'll see a function running, and it'll be on the right side of an equal sign, meaning that whatever the result of it is going to feed back to and store in a variable. Or it'll generate a value that's used to determine truth or false, like in an if statement or a while loop or something like that. That's a possibility as well. Right? Do you really need to know what goes on inside your thermostat in order to use it? Not at all. And one of the reasons why people use pre-built functions is because they just do what they're supposed to. But the kind of interesting thing about programming is this, is the more advanced you get at programming, and let's say you do this professionally, you will be in the situation where you write your own functions that do certain things that you yourself will end up reusing in your own program, so you don't have to reinvent the wheel each time. Right? You will find that a lot of really common things that you do in programming languages typically are pre-built. All right. So how do we implement and test these functions? All right. Let's take it step by step. All right. So they're going to start with an example here, and the example is this. To create a function that computes the volume of a cube with a given side length. So one thing you have to know about cubes is all sides are the same length, right? So all we need is one of the sides to give us the volume. All right, so the first thing that you would do is you would choose a name for the function. And so here they're just suggesting you call it cube volume. Makes sense, right? It's descriptive, tells you exactly what it does. All right. The other thing is you want to define, a variable for each one of the things you're going to throw at it. So if I only need one thing going into it, I only need to come up with one variable. So they're suggesting side length is a good variable name. So in order to actually define your function in Python, you're going to use this syntax that you see here. So you see the keyword def, which stands for define, the name of your function, followed by parentheses, and then sometimes those parentheses will have nothing inside, sometimes they'll have one thing inside, sometimes they'll have many things inside separated by commas. But this top statement is going to be required for all the functions you create. So in this case, we're just defining cube volume, and we're passing to it the parameter called side length. Then notice the colon at the end. So what comes next is the actual logic that follows. So that first line they call the header of the function. And you recognize it immediately because you see that little def thing. It indicates very clearly that you're defining a function. In other languages, these can be called different things. I just want you to be aware of that. So if you guys are learning Java, formally those are called methods. If you learn Visual Basic, you'll have functions and subroutines. If you're learning C and C++, they're functions. If you're learning JavaScript, they're called functions, right? But what they really are, folks, are a named block of code that has a series of steps inside of it, kind of like a mini program unto itself that will do certain tasks when called upon. All right. Once we get past like naming the whole thing, now we got to actually do the work. We can take the length of a side of any cube and cube it mathematically. So side length to the third power. That's what we have here. Or you can say side length times side length times side length, same difference, and store that in volume. And then we can just return the volume. So if I execute this function, I call it by name, I send it the length of one of the sides, it does the math, and then sends back to me the result. Pretty simple, really. It's not really that complicated. And why would we create this as a function? Because it might be something that we want to use over and over again. It's really as simple as that. All right. Completely written out, that function would look like this. We have our definition, Q volume, side length is being passed into it, the colon to show that we're defining it, and then the 2 lines of code inside. Notice it follows those indenting rules like all Python programs do. All right, that's a simple function. All right, how do we actually test the function? Well, first of all, we have to have that block of code, and I'm talking about this top part here, somewhere inside of our program. Now here's kind of the weird thing. In this example, they're putting the definition for the function at the top. That's not necessarily how you have to do it. Because it's being defined and it's being given a name, you can actually put it anywhere inside your code. Top of the program, bottom of the program. What most programmers will tend to do over time is when they write predefined functions like this, is they'll tend to put them towards the bottom of their code and then put the sequential logic for getting the program to run towards the top. A little bit different kind of approach. All right, so how do you test this? So the first thing that you do is you define it, then you go ahead and you run it. But notice when I run it, I know it's coming back with a return value, so it has to have somewhere to go. So I set up a variable to receive that value. So the first time I'm sending 2 to it, what's the result? 2 times 2 times 2, 8, all right? 10 times 10 times 10, 1,000, right? And then you just do a couple of print statements and have the results up on the screen, all right? When you're going through these processes, you know, they kind of reiterate all the stuff that we just talked about, the components of it, the header, the body, the statements, the name of it, the parameter, all that stuff. These are things that you will get comfortable with as we go. All right. All right, let's take a look at programs that actually utilize these things. All right. So they're doing a lot of repeat stuff here. But when we actually run the program, notice that in this case, they have this print statement, right, which is already a function. That one just happens to be built into the language. And then we're putting a function inside of a function. You can do that. Guess what, folks? Yes, you can, if it makes sense to. So if I run cube volume 10, it's going to go to my block of code down here, do the math, return what? 1,000 back in here. So this is going to print 1,000. So this is the weird part. Can I call upon it before it appears in the code, out of sequence? Yes, you can. And like I said, what the common thing is for programmers to do is this. They tend to first define all their functions and then execute them. So here's an example. I talked about this in, I guess, the previous section, that a lot of programmers, and Python is not an exception. If you think about like your Java programs, when you guys are learning Java, you find out right away the only way you're going to get a program to run is to put stuff inside the main method. That's what you guys call it, right? And if you don't put it inside that main method, nothing's happening on screen. If it's not in that main method, nothing is executing when you run the program. All right? Python kind of has a similar construct. all right? But this is how you would execute it. So first we define our cube volume thing. So you see that I got that all defined, and whenever I want to call upon it, I can use it. I also define a main method, right? So this is going to be typically found at the top of your program, and it's going to create all the major program steps that you want to execute. So for example, I want it to get my cube volume, store it in result, and print it. Right? That's my main method. But the main method will not execute unless I call it. That's a little bit different than Java. With Java, anything you put in the main method automatically runs. In Python, that's not the case. You have to tell it to run. Now, whether you're going to opt at this point in your programming career to utilize the main method, that's up to you. But as we get to more complex programs, it's going to be kind of become necessary, and you'll see why, especially when we start dealing with objects and classes. So that takes a little bit of practice. The question that I would put upon you is this, from what you've learned so far. Here we have a defined main method or function and a cube volume function that we built. Does the main method call, which is at the bottom, is that where it needs to be? Could I put it at the top and would the program still run? What's the answer? Yes, you can put it at the top and it will still run. There's conventions that people use. Ultimately, you're going to find something that makes sense to you. But the program, typically what people will do is they'll put all of their main actions in the main method that mostly will be calls to other functions. So it might be like cube it, print it, display it, cube it again, display it again, put it all in the main method, one call to main, and the whole thing runs. Meanwhile, main is like directing traffic. It's pulling in all the stuff from all the different things and getting it all to go. All right. They have examples here that you guys could execute and run if you so felt. And I'm just going to go back right up to the top here. So we're finishing with section 5.2.3 today. So we got through the first two sections of lecture. When we come back next week, we'll pick up in the next section, finish the lecture, and then work on the exercises. I would encourage you guys, though, to read ahead, and then we'll clarify the concepts in class, and maybe you should try at least a few of the exercises before you come to class, because they are due 2 days after class, right? So it's good to get a head start. All right, folks, this first lecture video ends here. Here.